Okay, so let's keep going. I just paused the recording. All right, let's keep going. All right. Okay, now there, what I did was I actually sketched. Wait, am I recording? Okay, so there, here that is, I actually sketched the graph of this, right? I mean, here we knew what it was going to look like beforehand. Maybe if you didn't, that's okay. But basically what I did to sketch the graph of this, I plotted some of the solutions and I connected them. And that's actually what you do in general to sketch a graph. So in other words, if you're given an equation in two variables, okay, you make a table of solutions, okay, like I did over here. But again, these x values, you can choose as many as you want, or any x values you want. I mean, you could choose a lot more with computer software these days. You plot the solution as ordered pairs in the Cartesian plane, right? So you get these ordered pairs here, and you plot them, okay? I mean, I plotted one, another point here, that'll come later, but you can plot them and then connect them by a smooth curve. Okay, yeah?
When you're plotting with the line, like once you plot all the points, you don't use arrows on the end, right?
Trying to think. You don't have to, no.
Okay, thank you.
You're welcome. Good question. You don't have to, no. Sorry, I hesitate for a bit, so, okay. But anyway, right, so you would plot the solutions and connect them with a smooth curve. You don't have to draw arrows on the end, as you can see. I mean, you can, but you really don't have to. I probably would leave the arrows off, to be honest, so. But anyway, here, that's what you would do. And of course, the more points you plot, the more accurate your graph is going to be. I mean, with things today, like with software, like Desmos or GeoGebra or graphing calculators, so this is probably, how do I say this? You could plot a lot more points than what I did. But this is the idea behind it. As another example, let's consider this. So we have y equals 4 minus x. We're going to graph this. I mean, in the next section, we'll see more accurately how to graph something like this. But for now, let's just make a table. So I choose some x values, okay? And again, if this was an exam or quiz or whatever, I'll give you the x values that I want you to use. So we have -1, 0, 1, 2. Again, I kind of chose these randomly. So when x is -1, what's y going to be? We calculate it. We plug it in, and we calculate it. We get y equals 4 minus -1, which is 5. So we have -1, comma 5 here. Right? So this is a point on the graph of this. It's a solution to this equation by this calculation. When x is 0, right, plug it in, we get y equals 4. So 0, 4 is another solution, right? When x is 1, we get y is 3. So this is a solution. And when x is 2, y we get is 2 as well. So that's another solution. And then we can plot the points as I do here. Well, I just plotted 3 of them. But we get the graph though. I guess I forgot to, although you can see it here actually, the 0.22. But you can plot them and then you connect them together. Kind of like connecting the dots, so to say. This one I made through Desmos actually, this graph. But again, that's the whole idea. You plot some of the solutions, right? I mean, again, with Desmos and stuff, you could plot a lot more than 4. You could plot probably hundreds or more, I'm guessing. But anyway, you connect them and you get the graph, and you can get the graph. So, of course, the more points you plot, the more accurate your graph is going to look like. Okay, here's another example. Sorry. Let's consider this now. Now, this graph you might not have seen before, although you might have, I don't know for sure, but anyway. So here we have our square root, right? We have y equals the square root of x. So here, what we're going to use for x, I would use perfect squares. Although I guess theoretically you don't have to because you can use a calculator. But I would definitely use numbers for x that are greater than or equal to 0 and perfect squares. Because you can't take the square root of a negative number, okay? So here, when x is 0, we have the square root of 0, right? Which is also 0. So this is on the graph of that. This is on the graph of that. When x is 1, right? We also have y equals the square root of 1, which is still 1. So 1, 1 is on the graph, right? Now again, just to make it easier, I'm going to use numbers that are perfect squares. Like 4 is a perfect square. Mostly because then when you take the square root, you get another integer. So the square root of 4 we get is 2. We have 4, 2. Square root of 9 is 3, as you can see. So we have 9, 3. So if we have these 4 points, they're going to be on the graph. Then you can connect them by a smooth curve, okay? And then you'll get the graph like this. I mean, I do keep on going as well. But this is the idea behind it, though. Okay. All right. But this is what the graph actually looks like. Again, I just plotted some points and I kept on going. So, all right. Hopefully that makes sense. Are there any questions on this? Okay. Here's some more terminology, actually. This comes up as well. We have this notion of intercepts. We have what's called the x-intercept and the y-intercept. Basically, what can happen is this. The graph can intersect the x-axis, right? But when it does, it's going to intersect it at a point of this form. Right? If you remember, since you're on the x-axis, the y-coordinate has to be 0. That's what has to happen. The y-coordinate has to be 0. Okay? Now, the x-coordinate, here I called it A. This is actually what they call an x-intercept of the graph. So again, if a graph intersects the x-axis, it's going to intersect it at a point like this. And the first coordinate, the x-coordinate, we call it the x-intercept of the graph. I mean, I'm trying to illustrate that here with a circle. You know, here, for instance, I'm saying that the circle intersects the x-axis at the point 2, 0 and at 5, 0. So here, 2 and 5 would be x-intercepts. Okay, x-intercepts are numbers, not points. And for y-intercepts, it's the same idea, except they intersect the y-axis. So in that case, the point would be of the form 0, b. Right? Because again, if you're on the y-axis, your x-coordinate has to be 0. So whatever that y-coordinate is, that's the y-intercept of the graph. And as this graph here is showing, you could have more than one x or y intercept. I mean, here we have 2 x-intercepts. And it's also possible you don't have any x or y intercepts, right? This circle never intersects the y-axis, as you can see. It never intersects it. Okay, so that's what these intercepts are. Now, there are different ways of finding them. You could graph, the equation, you know, sketch the graph with like Desmos or something, or you could solve for them algebraically. To solve for them algebraically, this is what you would do. Namely, to find the y-intercept, right, you would have to let x be equal to 0 and solve for y, right? That's what you would do. That's what the definition is saying, right? When x is 0, whatever the y coordinate is, that's going to be your y-intercept. Also, for the x-intercept, right, same idea, you just let y be 0. Namely, here you want to get this kind of point, right? Well, how would you get that point? You can let y be 0 and solve for x. You know, that's what you can do. But that is what you can do here. Okay. So that's how to find them algebraically. I mean, of course, though, you can always sketch the graph of it. In the past, what I've done is I've asked students to find the x and y intercept without using a graph. But this is what you would do. So here's an example, actually. Namely, suppose we have y equals 2 times x minus 1. Okay, I mean, I did sketch the graph here. This is the line that we saw earlier. Okay, how would you get the y-intercept? Well, here from the graph, you can see that it's at -1, right? That's where the line crosses the y-axis, okay? In other words, this point here is of the form 0, -1. Or you could just do this. You set x to be 0, right? And you solve for y. And you get -1.